Okay, for those of you who just joined us, I'm Nick Tedeschi. I'm with ANKOM Technology. I'm joined here with Chris Kelly, and we are going to talk about cutting costs of dietary fiber analysis using the automated ANKOM system. I'm going to go back a little bit. If you're not familiar with ANKOM Technology, we design and manufacture laboratory instruments. We generally find procedures that are difficult, tedious, and time-consuming, the methods that people really don't like doing in the laboratory, and we automate them. And dietary fiber, it fits this description very well. So I'd like to give you a little bit of presentation, a plan for presentation, so you know where we're going. We're going to start by talking about the instrument development, and we're going to go certainly not through the whole instrument. That can take a long time. It's got quite a history. We can talk about that at a different time. I think we need to cover some of the basics so you can understand how it saves time and money. After that, we're going to talk about we're going to compare the manual versus automated procedures, and then what the core of the talk is going to be based on, or it's going to be reflecting the cost analysis. All right, so that we're all on the same page, I'm going to use classical, conventional, I might even refer to manual, and Chris will do the same thing. Anytime classical, conventional, or manual is mentioned, we're talking about the traditional method that is done in the laboratory on the bench top. Generally uses a lot of glassware. It's time-consuming, it's tedious. They can be, volumetric, titrometric, gravimetric. There's a lot of different categories. All right, so when ANKOM decides to automate a procedure, one of our main goals is to maintain the original chemistry. We are not reinventing the wheel, we are just automating it. So these methods run exactly like the manual method. You're going to end up with the same results that you would had you sent it to another lab that's not using the ANKOM system. And these results are going to be comparable to anything that you've received traditionally over the last several years or decades. With any system, if someone wants to use it, it's going to have to be easy to service. And no one wants to handle in a system that's difficult to use or to service. So ease of service is one of our primary goals. Ease of operation goes right along with ease of service. We want anyone really to be able to be trained in a short period of time and to be proficient with the instrument pretty much first time they use it. All right, automation generally automatically increases precision because it removes human techniques. Gets rid of the variability between operators. All right, our system is about 48 inches wide. It takes care of the entire process, where the manual procedure has usually 2 water baths, vacuum filtration manifolds, and lots of flasks and glass are all over the place. So our system requires a lot less space. Of course, with automation, the concept behind automating something is that it reduces the amount of technician intervention. Your folks can do other things in the laboratory, and of course, that lowers your per assay cost.
So let me go a little bit into the background of the system and really how we design it. I'm Chris Kelly, as Nick said before. The issue was, and I went one slide too far, the issue really is when we looked at dietary fiber analysis and said, is this a process that we can automate? There clearly is a problem in the design process, and that is, how do you automate a method that requires so many different steps? There's 3 different enzyme steps. There's 2 different temperature requirements, a pH change. Then you have to transfer and filter the sample. If you're doing insoluble and soluble, if you're trying to get both of those fractions, you have 2 filtrations. If you're doing a total dietary fiber, you're talking about a digestion followed by a precipitation and then a filtration. So all these steps that require manual manipulation, how do you automate them? And so the key was, or the aha moment, if you will, was the development of what we call the dual chamber filter bag. And it's that dual chamber filter bag that allows us to, if you will, have one section of the filter bag act as the beaker, while the lower portion acts as the filter. So that allows us to separate both the digestion and the filtration. Yet we're able to design a filtration matrix that matches the Gooch crucible. You have to remember that by method, the Gooch crucible has a porosity of 40 to 60 microns, and that porosity is made finer by the use of diatomaceous earth. That's why it's so important, creation of the diatomaceous earth bed in the crucible, and quite frankly, how it's handled throughout its process. If that diatomaceous earth is disrupted significantly, it is going to affect the filtration matrix. In our case, we've been able to develop a filtration matrix that has a porosity of 8 microns or lower, and then we use diatomaceous earth at least in one of our phases just to aid in the filtration, but the porosity itself is already set by the filter bag itself. The other thing is that we had to design filter materials that would support the different surface tensions of the solutions. You have an aqueous solution in the upper section, you have an ethanol-based solution in the lower section, different surface tensions, so we actually have different filter materials in both the upper bag if you're doing insoluble dietary fiber, and the lower bag if you're doing either or if you're doing total dietary fiber, or in that case you're capturing the soluble dietary fiber, depending on what method you're running. So by creating this dual chamber filter bag and then basically designing an instrument around that allows us to have separation points. You could see here is a separation point from between the upper section of what we call the SDF bag and the filter, and up here in this case we're showing what's called a flow-through bag. In this run, the laboratory is running just a total dietary fiber, so there's no filtration point here. There still has to be a separation because we obviously don't want the digested filtrate to go in until it's the appropriate time. On this right-hand side, you'll see perhaps a better close-up showing both the insoluble dietary fiber bag in the upper section here, and the lower one has the SDF bag. So again, separation points, filters, beakers, if you will, on the other part of it. So that's the design there. What this really does for us, our design of the dual chamber filter bag is, one, it eliminates the manual labor element. There's no constantly returning to the filters to scratch the surface of the gel, to break up the gel in order to enhance your filtration. But with our bags, we're talking about increased surface area. So this is a picture here showing the lower bag for a total dietary fiber analysis. This bag here, this filter, has a little bit more than 2 times more filter surface than a Gooch crucible does. Our upper bag, or the IDF bag, has 4 times, a little bit more than 4 times the surface area. So that's one of the main reasons we're able to, one, filter faster, but also eliminate the need for a technician to come by in order to manipulate the bag, or in this case, in our case, bag, but they don't have to manipulate that. But with a Gooch crucible, they would have to go and scratch the surface of the gel in order to increase or enhance their filtration. This is a video. I'll speed up at times, but this is just to show the difference between what people would normally tell us are difficult to filter in their conventional method. Oat bran here on the left, pectin on the right, and then we have the same thing going on here on the bottom section with the conventional method. I'll input here that I did both the automated and the conventional method in these. So you can see, and we have positive pressure that we're pushing down versus a vacuum here. And you can see that the filtering happens quite rapidly. Many of our samples, quite frankly, are under a minute. But oat bran and pectin would be ones that normally would take longer period of time. So you can see that there's still some filtering happening here. The pectin, because the way pectin is, it is causing some gel, so it's much slower filtration here. But here on the conventional side, I'm still working on getting the solution in for the oat bran. So you can just see that this is taking time to filter. Again, in this case, the oat bran will be finished first, but the system won't start its next step until all of those are filtered. So I'm going to move this up just a little bit just to see a little bit faster. So the oat bran finished just the filtering, not the rinsing part, in 2 minutes and 15 seconds. Over here, I'm just starting to pour in the pectin in the conventional method. Again, I've got I believe it's a 50 or 60 milliliter Gooch crucible, and I've got almost 400 milliliters of solution. So there's constant need to replenish that Gooch crucible. So I'm going to speed it up again a little bit more. There, the pectin finished its filtration in 4 minutes and 21 seconds. Now, over here, automatically, without technician involvement, the rinses take place. In the case of a total dietary fiber, we're talking about 2 78% ethanol rinses, followed by 2 95% ethanol rinses. Back down here in the conventional, the oat bran is still filtering here. The pectin is filtering, and I'm still having to continue to put solution in there because of the slow time it takes to do that. So rinses are taking place here. Let's go ahead and speed up again. Okay, so the rinses almost finished on this side. Remember, a total of 4 different rinses that have to take place here. Here, oat bran is still filtering, pectin is still filtering, and still trying to get the beaker emptied. We'll go ahead and speed up a little bit here. One of the things that's interesting about when I did this, there's your time, 8:28 for total time for oat bran, 10:24 for the other ones. So we'll just write those down just so I don't forget them. The thing that was interesting about this is my goal in this presentation was to be able to show just how much time difference there is between the methods. But I have to be honest with you and tell you that when I was doing the conventional method, in the beginning I was being very careful just to scratch the surface of the gel as the method requires, because I wanted to do the method exactly as according to the way it's supposed to be done. But, you know, I have lots of other work to do during the day, so I got to the point with the conventional method that I started digging in and actually going all the way to the glass because I just had to get it to speed up a little bit. So I'm the person that's trying to let you see how much of a long difference there is, but even in my frustration, I ended up cheating, so to speak, in order to speed it up. Well, now put that on a technician that's got lots of other work to do. The same thing can happen, and that's what causes problems with both accuracy and precision. So the system's still going. We're doing the rinses on the oat bran. We're still trying to filter the pectin. So I'm just going to speed this up because I don't want us to spend a lot of time just looking at it. I think you get the point. The bottom line is, as you saw, there was 25 minutes. Excuse me, I started to go back and I missed it. About 25 minutes for the oat bran to get completed, and it's going to be about 1 hour and 49 for all the rinses and everything. Let's get there. There, 1 hour and 49 minutes for the pectin. So for anybody that wants to see this entire video, we can send it to you, or we can point you to our YouTube channel so you can see it. I just did not want to waste a lot of your time just looking at a video showing filtering. But the bottom line is, because of the increased surface area, because of the automation that we've designed in the system, we're talking about filtration, even for difficult samples, to be considerably below that of the manual method without any technician intervention. I'll mention to you, for instance, we do a psyllium husk, which cannot be done in the conventional method through Gooch crucibles. There's actually a modification to the method in AOAC that can use a centrifuge to handle samples like psyllium husk. But we can do a total dietary fiber on psyllium husk. It takes about 20 minutes for that to filter. So that just gives you an idea of the difference. I would say 75 to 85% of the samples that run through the system, and we've done thousands of different samples from all over the world, are under 2 minutes in filtration time. So we wanted to really highlight the difficult samples for this presentation. So what's the real difference? How can we graphically show the difference between the conventional method and the same method run in automation? So here's the conventional method, again, just highlighting 991.43. there is a number of things that have to be done, from preparing glassware to adding solutions to doing the transfer to doing the filtering to doing the rinses. This is what the conventional method looks like. You can see on this chart it shows 35 steps, but obviously there's a number of steps. Obviously, prepare a Gooch crucible, you could basically put these two together, but there's another 5 steps or so here, so we're at 40 steps there. It does not include the times that you have to scratch the filter bed, really the gel surface, in order to continue filtration when you're going through a filtration process. That can be a lot of return times, as you might have seen a little bit on that video that I just showed you. Those are things that have to be take place in the conventional method. Well, for the automated method, we still are running the method. That's the focus, as Nick said before. We don't want to change the method. We want to run the method as it is required. All the chemistry is the same. But because we're using filter bags, we eliminate the need for the crucibles. And so we eliminated all those steps. When it comes to the insertion of the solutions and the heating and the adding of the acid, for instance, for the pH change in this method, all that is done automatically. All you have to do is check and adjust the pH after the acid has been added. When it comes to isolating both the IDF and the SDF, in other words, doing the filtration process and the rinsing, in the automated method, all that is handled automatically. All you have to do for both the insoluble dietary fiber and soluble, if that's what you're doing, is rinse with acetone. You're going to dry the samples in the filter bag, and you're going to weigh them. For both the conventional method and the automated method, of course, there is the protein and the ash correction. But if you look at it, we're talking about 12 steps versus, greater than 40 when it comes to the conventional method. So that gives you just an idea of the whole system. Some of you have listened to this kind of information before, and sometimes even in greater detail, but we do want to put our focus, if you will, on cost. So I'm going to turn it back over to Nick, and he's going to give you a little bit of the assumptions that were built into the cost analysis.
Okay, thanks, Chris. When we put these numbers together, we want to use conservative estimates. We don't want to make our instrument look greater than it is. We don't want to make a promise that we can't keep. So we've been conservative, and we've used supplier costs and a lot of these supplies, a lot of things that you can get like online through VWR, Fisher, things like that, all these online places. So we use their average cost for a lot of this material.
We also use Megazyme's enzyme costs. This is directly from Megazyme. We do sell a pre-concentrated enzyme from Megazyme. It's the exact same enzymes, but Megazyme was kind enough to go ahead, and actually they sell it as well, to make the dilution. So it's very simple to put together the solutions in our system. I believe it's 5 milliliters, 5 milliliters volumetrically brought up to 25. That way you don't have to worry about sodium azide. You don't have to worry about glycol. It's exactly the right concentration to work with our automated system. If you buy Megazyme, the non-concentrated solutions, if you will, or anybody's enzymes, then we do provide dilution instructions, because it's very important that the right amount of enzyme gets delivered at each station in our system. So those are the prices we're using, and we did, when we looked at VWR and Fisher, we also assumed that people get some discounts on those, because it's typical that they discount their products. So we also figured that in our suppliers' costs. Okay. Gooch crucibles, by the way, is a good example, Phil.
Right. So we used $20 for the Gooches, and we're assuming that you're not breaking them at all, which we know they do break on occasion. We're also assuming that there's very limited glass breakage, maybe 1 or 2 pieces per 1,000 analyses, which we know is probably happens at a higher rate than that. The wages we based on $15 an hour. I mean, you may be more or less in your lab, but we are not including benefits or health care or anything like that. Those can definitely increase the cost of labor a great deal. So with all that being said, And with the background that we just went over, here's what it boils down to. So here's the chart. So the enzymes for the manual system is about $1.42 per sample. With our system, it's about $1.89. Again, we're being honest because the system flushes the lines.
Line charge.
Line charge. Yeah. Charge is a better word, not flush, but charge. With a little bit of enzyme, so it uses just a little bit more. Solutions, about $26 for the manual. And again, just a little bit more for our system because we charge the lines. Glassware, we're assuming...
We should talk about that line charge a little bit. The line charge is done when, when the instrument's set up, but each day that you start, if let's just assume the instrument's off, when you start the instrument at the beginning of the day, it's going to do a line charge because it has to make sure all the solutions are at the right point. So that initial line charge is going to put some solutions out, and then when that first run happens, it's going to basically move solution again, because it's going to be setting up for the next one. So that's what happens, that small amount of solution that's going, and some of it is going to go out, if you will, the waste tubes of the system. As long as the instrument is not turned off and there's not a 12-hour waiting period between runs, then it will not continue to do a line charge. So most labs, I'm sure, are running at best 2 shifts. So each morning you're going to get a line charge. And so we factored that in. We're assuming that there's going to be a line charge every day done. So that's how we factored that in there.
All right, so that line charge is really just your first run of the day. All right, so as far as glassware goes, we're assuming a very low amount of breakage, maybe 67 cents on average for the manual. The bags are the consumable for the automated system, so that's about $4.50.
But by the way, we can throw something in here that's kind of important. That $4.50 is based on, Nick, remind me, that is a TDF.
That's
right?
TDF.
That's TDF. So it would be obviously more if you were doing both insoluble and soluble dietary fiber in that. But when it comes to TDF, the upper bag is what we call a flow-through bag. And perhaps counterproductive from a company that has the consumable, we tell people right up front that the flow-through bag, because it does not go through a protein or an ash process in there, that is a bag that can be used more than once. And I was recently in Thailand, and we're using them 4 times. Probably could have got more use than that, but for the sake of the time that I was there, we used the bag 4 times. So that reduces that cost by a considerable amount. I think that would actually make the bag about 17 cents.
Yeah, something like that.
No, less than a quarter. So it would be about 17 cents for that. So that would reduce that cost as well. But again, we're just using prices as it is, figuring 1 use each.
All right. So the fourth line down is the big one. So you can see that the labor during the manual analysis is about $40 per sample. The person's spending 2.5, maybe even a little more than 2.5 hours per sample, where our system, someone who's got some experience with it, can get the thing set up and running and spend about 30 minutes complete for 3 samples in duplicate. So it comes down to quite a bit less time, and then of course time is less money. So
probably should interject there that the 30 minutes is based on our main lab technician. We don't run a commercial lab, obviously, but we get samples from all over the world of people that are interested in the system and want to see their results before they buy. So he's quite proficient, and it's going to take, I would say, most technicians will probably take a little bit longer as they're getting used to filter bag technology and using it. But I would expect they're going to be able to match him, in some cases be a little bit better than he is at some point after they get familiar with the system. But 30, 40 minutes per complete run is a legitimate value in there.
Yeah, the instrument is really very easy to run. I think any technician within 4 or 5 runs is going to be very proficient. You're just weighing bags and samples and putting them on the instrument. It is not hard at all. In fact, I think anyone can learn to get down to 30 minutes within 3 or 4 runs. So the total here is looking at $68, a little over $68 for the manual, about $35 for the automated. So that's about a 60% savings. Well, that's a little more than 50% there. That's conservative.
Yeah, I think it's like 47, 48, yeah.
So what we get from our current current customers, the feedback we get from our current customers over the several years that this unit has been out is anywhere from 50% as high as 75% savings in cost. We had one customer who claims that they can do the conventional for $46, which seems pretty cheap. I don't know what their labor rate was, but they are also saying that they can do the automated system for $17. So that's right around 2/3, maybe 66% savings approximately.
Yeah, this was actually a laboratory that has now increased their systems from 1 lab to 3 labs now. So they're real happy with those cost savings.
Right, and then we were at another customer who claimed that they would save about $500,000 per year using our system. And again, we don't know what they're paying the contract lab for the analysis, and we don't know how many they're sending, but it must be they're sending quite a few and they're paying quite a bit to save $500,000 a year. So again, the minimum we really see is about 50%, and that's with our calculations. We've seen as high as 75%. I don't think we've got any customers. Chris, we have any customers that claim that they were having less than 50% savings?
No, I'm not. It's interesting, kind of going back to that $500,000 per year. Both Nick and I actually were there when the director of lab made that statement, and our jaws kind of dropped because we couldn't figure out how they could save that much money. We didn't think their volume was really significant enough to do that. But we do know that they were sending them out to a commercial lab. We don't know the cost they're paying, as Nick said, but I have seen costs as high as $275 per sample. So, you'd still have to do quite a few samples. So, we have to just be honest and say we think that there was some exaggeration to that. But the point we really want to make is that those weren't our numbers. That was a statement by a person that went to our system. So it's pretty interesting to see what we hear out there. But the bottom line is 50 to 75% savings is not unexpected.
All right, that's right. Okay, so that pretty much brings it to an end. Now, on the right side of your screen, there'll be a little chat bar. Feel free to put questions in there, and we will definitely be around long enough to answer any and all questions. If you want to see this presentation, we can send it to you. If you want to see it again in detail, if you have different costs on glassware, chemicals, and you want to see the really detailed, long, drawn-out cost analysis, we can do that for you. So we'll give you contact information. Send me that information. I can send you your specific cost analysis.
We can actually send you the spreadsheet if you want, and then you can plug in your numbers because some people don't like to share their numbers necessarily with us. So we gladly would share the spreadsheet with you. That way it at least gives you an idea of things you have to put in, then you can put those calculations in. I tell you that I was telling you I was in a laboratory in Thailand last couple months ago actually, and when they did their cost calculations, they were actually figuring in the cost of the water baths for the conventional method, the time in the water bath. I mean, they were figuring it to a very high degree, which was quite interesting to see. Ours is basically an account for labor, enzymes, solution, glassware. That's our focus on there. If you amortize the cost of the instrument, obviously that's going to have an impact. And then do you amortize it over 3 years, 5 years, things like that. So these are really talking about the direct cost in this analysis. But anything we have, we're willing to share when it comes to spreadsheets and things like that. But we want to address any of the questions you have, any of the pushback, quite frankly, you might have as well. And that's available via the chat line. We will be posting this entire webinar on our website in the near future as well. But why don't we go ahead and stop the presentation part and move then to your questions.